so we can put all this together into a big problem like this one. First, we want to find the simplest formula. We're given the percent of boron and the percent of hydrogen, and then we're going to figure out the molecular formula. So first things first, let's find the simplest formula. And again, we're given percentages, so I'm going to assume I have 100 grams total, and that makes my 86.53% into 86.53 grams of boron. And I want to get that into moles. So I use my molar mass from the periodic table. 1 mole of boron, 10.81 grams of boron. So I have a total of 8.00463 moles of boron. I do the same thing with 13.47% hydrogen, so I change that to grams of hydrogen. Find hydrogen on the periodic table, 1.01 grams per mole. So I have 13.3366 moles of hydrogen. Next, I want to get those into the smallest ratio of whole numbers, and I do that by dividing both of them by the smaller number, 8.00463. So I'm going to get an answer for the boron that's equal to 1, and for the hydrogen I'm going to get an answer of 1.66. Now again, 1.66, too far away to round it to a 2, too far away to round it down to a 1. So here's where I have to multiply, and if I try multiplying by 2, it's not going to give me a whole number. If I try multiplying by 3, 1.66 times 3 is 4.98, and that's close enough that we can round that to a 5. Remember, you have to do that for every element in the formula. So if I multiply the hydrogen by 3, I have to multiply the boron by 3. So that gives me the simplest formula of 3 boron and 5 hydrogen. So that's step 1. Part 2, we want to find the molecular formula. So here's where we have to do the scaling factor. Scaling factor is a ratio of the molar mass of the actual, the molecular formula, divided by the molar mass of the empirical, the simplest formula. And the problem tells us what the true molecular formula, molar mass, is 112 grams per mole. So that's the numerator. The denominator, the molar mass of the empirical, remember we got B3H5. So if I use the periodic table, calculate 3 moles of boron, 5 moles of hydrogen, that's going to give me a total of 37.48 grams per mole. And when I divide, I get a scaling factor of 2.99. But remember, scaling factors will be whole numbers. 2.99 is close enough to call that a 3. So now I take my simplest formula, B3H5, and I multiply each subscript by the scaling factor, and my true formula is B9H15. Now, it wasn't in this case, but in another problem, it's very likely that your scaling factor could be a 1. And all that means is when you multiply by the scaling factor, your subscripts will not change. So if your scaling factor is a 1, then the simplest formula will be exactly the same as the molecular formula.